Now we're going to talk about slope. This is something that you will be using probably the rest of the time you're in algebra, in high school, in college. Welcome to slope, okay? So the slope is telling us the steepness of lines in the coordinate plane. So if you think about skiing and they talk about the slopes, it's the tilt of the mountain, okay? So we'll be doing an activity that you'll kind of get to play with the steepness and see how the numbers all relate. Mathematically though, algebraically, when we talk about the slope, it's the vertical change, okay, you're changing your y's, over the horizontal change, or the change in your x coordinates, okay? So your book has it both of these ways. A lot of times the quick way to say it is rise over run. You'll probably hear this more than either one of these, okay? The rise, which is your vertical change, over the run. Okay, so if you haven't already copied these down, please do that. So part of your problems will give you a graph and you have a line and they'll ask you to find the slope of the line. The first thing you need to do is to find the coordinates of some of the points. You want to look for where it actually crosses, if possible, on the grid, okay, instead of kind of in the middle of a square. So if we look at this point, it would be -1, 2. So I'm going to just write down my points. So I have -1, 2, and this one, they've already given me some points to use, is 1 over 1 up 1, 2, 3, 4. So 1, 4. Okay, so those are the points I'm going to use. Now, going back to our slope definition, is the rise over the run. There's a couple different ways you could do this. You can look at the graph and you could look, okay, how much did we rise going from the point on the left to the right? Well, we went up 2, then we went to the right 2. On a graph, both of those directions are positive. Going up is positive, going to the right is positive. So the change, our vertical distance was 2, our horizontal change was 2. Okay, so our slope would be 2 over 2. Rise over run. Change in vertical distance over change in horizontal distance. Change in y over change in x. Okay? You can go ahead and simplify this to 1. Alright? If you look at the points, okay, that is the change in the y coordinates over the change in the x coordinates. So I always write this. I draw my bar, okay, because slope is usually going to be like a fraction, okay, unless it simplifies to a whole number. So you want the y on top and the x in the bottom. You have to match the coordinates, okay? What I mean by that is if I'm using 2 in the top first, okay, I'm going to choose that y. I have to put -1 underneath it. Okay, so xy of 1 point. Now, is the change in our y and the change in our x, so we're looking at subtracting those. What is the difference? So now I'm just going to write my other point. 4 over 1. Okay, so if you take 2 and subtract -4, you get -2. If you take -1 minus 1, you get -2. What does this simplify to? 1. Okay? A lot of times you'll see this represented as y2 minus y1 over x2 minus x1. All that means is that here's one of your coordinates, here's the same coordinates, okay, or here's another point, the x and the y are paired, okay, these x and y are paired, and you're subtracting them, okay? So now, let's get another problem. So here's a graph. If you can't see this, I'll give you the points in just a second. I want you to find the slope of this line on your own, and then press play and we'll check. So this point is, our first one is, oh, whoops, sorry. Forgot the pen. So we have 1, -2, and then this lower point is 2, -4. Okay? So if you use the graph that we've gone down 2, okay, because going down in a graph is negative, but we've gone to the right 1. That again, we always want to go from the left point to the right, okay? Actually, you don't have to, but I always do because that's the way we read. So, -2, 1, so the rise, our change in our y, our vertical distance was -2 over 1 over our run, so that simplifies to -2. If you did this with the coordinates, it doesn't matter which point you put first. I'm just going to use -2 over 1. Okay, flip this one. Subtract, subtract, -4 over 2. Okay, so -2 minus -4 is, that's going to be adding a positive, so that will be a +2 over 1 minus 2, which is -1. 2 divided by -1 gives you -2. Either way, you get the same slope. Okay? So now let's try basically the same thing, only in a little different form. It says graph the following data and find the slope of the line. Alright, so first thing, we have to graph this. So 0, 0 would be here. I keep forgetting my pen. 0, 0 would be here at the origin. -1, -3 would be here. Whoops. -2, -6 is going to be down here. And then -3, -9, I'm off the chart. It's about down here. I can make the dot. Okay. For these, if your points don't make a line, then you did something wrong. Okay? So we graphed our points, we'll connect them with a line. Be sure your line's big enough to see. Now, to find our slope, again, you can use the graph or the coordinates. So I want you to pause it, try to find the slope on your own, and then press play and check. Using the graph, we go up, then over, so we go up 1, 2, 3, to the right 1, so we rose 3, and then the run was 1, so the slope is 3. Using the points, you can use any of these points. I'm going to use 0, 0 because that's very easy with my math. Okay? I'm going to start with the -3 over -1. Okay? Flip it. Minus, 0, 0. Use this as my other point. Okay? So here was one point, here's the other point. So -3 minus 0 is -3. -1 minus 0 is -1. -3 divided by -1 simplifies to 3.